In part 2 of the problem string equivalent ratios, we're going to look at problems that involve dividing with fractions. So we're going to start with this first problem here. And it says, if a student walked half a mile in 30 minutes, how fast was he walking? What was his pace per mile? So again, we want to get the miles to 1, except this time we only know how much they walked in half a mile as opposed to, or how long it took them to walk half a mile as opposed to how long it took them to walk multiple miles. So think about what would we do here? How would we solve this problem? How could you use a ratio table? If you want to pause the video and work it out on your paper, you can. Otherwise, we'll go ahead and continue. So for this problem, you can set it up with a ratio table. Again, they're going to stick with minutes on the top and miles on the bottom just for consistency here. So they put 30 minutes at the top and then miles is a half. And so in this case, to get from a half to 1, we need to multiply a half by 2. So we end up with 1 half times 2, 2 halves would be a whole. And then 30 times 2 would be 60 minutes. So they walked half a mile in 30 minutes, so they need to double that to get to a full mile, which takes them 60 minutes if they continue at that pace. Let's look at another example here. If a student walked a quarter of a mile, 1/4 of a mile, in 5 minutes, how fast was she walking? What was her pace per 1 mile? So think about how you would set that up with a ratio table. Pause the video if you'd like to solve it on your own first. So to set this one up, and there's a couple of different things in this one here. So one way that we could do this is we could put the 5 and the 1/4, and maybe you already know that you should multiply 1/4 by 4 to get 1 whole, because that's a common benchmark fraction that we know and can work with really easily. And so we can then multiply the 5 for the minutes by 4 also and get 20 minutes to walk the 1 mile. You could also double and double again. So doubling a 1/4 becomes a half, double the half to get a whole. Double 5 minutes, you end up with 10 minutes, and double the 10 minutes, you end up with 20 minutes. Either way, you get the answer of 20 minutes for her to walk 1 mile. Let's look at the next example. If a student walked 1/4 of a mile in 8 minutes, how fast was he walking? What was his pace per mile? If you'd like to solve this on your own, pause the video now. And the solution for this one, again, you can multiply by 4. You could double like you did in the previous one, but likely now that you've seen just multiply by 4, most of you probably were thinking that. And 8 times 4 would give us 32, so it would take him 32 minutes to walk 1 mile. Think back to that fruit pizza and what your classmates did. Some of those fruit pizzas were to make half a pizza, and then you would have to multiply here instead of divide to solve those. If a student walked 1/5 of a mile in 5 minutes, how fast was she walking? What was her pace per mile? Pause the video if you'd like to work this out on your own now. So for this one, think about how many 1/5s do you need to make a whole mile? Hopefully you're thinking 5. So you can just multiply by 5, setting it up with minutes on the top, 5 minutes, miles on the bottom, 1/5. Multiply both of those numbers by 5, and we end up with 25 minutes for 1 mile. And then our last one here, if a student walked 1/10 of a mile in 1 minute, how fast was he walking? What was his pace per mile? Interesting. Thinking. Pause the video if you'd like to. And the solution here is that, oops, that didn't seem where I want to go. One minute in 1/10 of a mile. And so we're going to multiply those by 10. I'm not sure why I can't erase that part at the bottom. But we're multiplying the top and the bottom by 10. And so we end up with 10 minutes to walk 1 mile. So in the last problem string, I had a question on the slides that asked you to think about who who ran the fastest. So in this case, all of our students are walking, but let's think about that. How do we know who's walking the fastest? Well, let's think about student 1. We'll call this student 1. Student 1 walked 1 mile in 60 minutes. Student 2 went 1 mile in 20 minutes. So was student 2 faster or was student 1 faster? Hopefully you're thinking student 2 because less time means that I went faster. Student 3 walked 1 mile in 32 minutes. Well, that's not faster than student 2 because student 2 got there in less time. Student 4 did 1 mile in 25 minutes. So they're still not faster than student 2. So far, student 2 is the winner. They're the fastest. They did 1 mile in only 20 minutes. Less time means faster. And lastly, student 5 could do their mile in 10 minutes. I'm not sure that's a walk. That seems more like a run to me. But this would make student 5 the fastest. They can cover the same amount of distance in less time than the other 4 students, so they are the fastest student. So this problem string is really similar to the one that you did before, only this time when we work with the fractions, we have to multiply instead of using that division. Both show you, though, how you could use ratios to solve these problems.